panagdait sa Dios ug sa tanang kabuhatan, and welcome back to DRRR 11. For today's lesson, our topic is about earthquake hazard and risk reduction methods. For our objectives, you are expected to identify various potential earthquake hazard and ways to minimize it, appreciate the value of preparedness and resilience in disaster situations. Please disregard the third objective. For our review, let us first define earthquake based on your understanding. Kindly pause the video and try to define it using your previous knowledge. You may pause the video now. I will assume that you already had your answer. Let us now check the definition of earthquake. It is what happens when two blocks of the earth suddenly slip past one another. The surface where they slip is called the fault or default plane. So earthquake is very easy to understand, and we already know about this one since you already talk about this in your other subjects, particularly in science, and you already always have watched it during news. Another review, let us talk about earthquake hazard. In your in our previous lesson, we have differentiated hazard and disaster. This time I want you to define earthquake hazard using your own words, and please pause the video. Once you are done, you may play the video again. I will assume that you already had your answer. Let us now check the definition. Earthquake hazard refers to earthquake agents which have the potential to cause harm to a vulnerable target, which can either be humans, animals, or even your environment. So when we say earthquake hazard, it is quite different to disaster. Please note that hazard refers to the threat, while disaster refers to a harm done to humans. Meaning, hazard kay threat pa lang siya and wala pa siya victims. Well, disaster, these are phenomenon or these are catastrophes wherein nana siya mga victims nga humans. So, in our case, we are still talking about earthquake hazards. So, mga phenomenon or concept pa lang ni siya, meaning these are mga threats pa lang for humans and the society. Meaning, wala pa siya naapektuhan. The effects of an earthquake can be classified as primary or secondary. So there are two classifications of the effects of earthquake. The first one is primary effects. These are permanent features an earthquake can bring out. Example includes fault scarps, surface rupture, and offsets of natural or human constructed objects. When we say primary effects, this refers to the direct effects of earthquake, or this happens during the earthquake itself, such as the examples: surface ruptures, fault scraps, offsets of natural or man-made construction objects, for example, the collapsing of a building or bridges, or the cracks of the roads or the ground. The secondary effects happen when ground movement results to other types of destruction. Examples include landslide, tsunami, liquefactions, and fire. For you not to be confused about the difference of primary and secondary effects of earthquake, please take note that the primary effects happens during the earthquake itself. That's why it is called primary, because it happens during or at the same time with the earthquake. Secondary effects, it is called secondary because it happens after the earthquake, or after how many hours after the earthquake had impact. Examples are landslide, tsunami, liquefaction, as well as fire. And please also remember that secondary effects also refers to another type of destructions that are brought by the earthquake. So therefore, the secondary effect, it also refers to other disasters which happens after the earthquake. Okay? So primary is katong distractions that happen during the earthquake, while secondary are distractions that happen hours after the earthquake. It can be another type of disaster such as landslide or tsunami, for example. Tsunami is not an earthquake, but it can be caused by an earthquake. Also landslide, fire, and liquefaction. In the following slide, we'll be discussing the following secondary effects of earthquakes, starting with landslide. It's landslide started by a seismic vibration, which is a common triggering mechanism for landslide. So seismic vibration refers to the movement of the earth. So it or what we call earthquake. Earthquake is a massive seismic vibration. So the earth is always moving. It is always the earthquake is always moving. That is what we call seismic vibration. But when that movement is exaggerated or kanang na over na ang movement, that's the time nga it will be called as an earthquake. So therefore, the earth is normally moving through vibration, but sometimes naay mahitabo nga earthquake wherein massive na ang vibration or the movement. And ang cause ana is katong magbangga ang two different grounds. Devastating effects like floods, blocking of rivers, death, and damage to land and natural resources. So since landslide is a separate, can be a separate disaster of earthquake. So for example, kung naay earthquake, it is possible that another disaster might occur, such as landslide, and it might cause another type of harm or danger to the people or the inhabitants of that certain land. So it might cause the following floods through the blocking of rivers. If the rivers are blocked, so and it cannot flow, there's a possibility that it will overflow, no? And it might cause flooding and further destructions to its surroundings. It might also cause death, of course, and damage to land and natural resources, for example, crops and other properties. Landslide can be prevented by reinforcing slope material, modifying the pathway for surface and underwater, and by putting pile and retaining walls. So you already know that landslide a always occur in a side of a big mountain, for example. So in some cases, in order to prevent that one, officials or experts constructs a somewhat like a firewall, or what we call the retaining walls, okay? Putting piles and retaining walls in order to prevent further damage kung naay landslide. Bali, those retaining walls are made of concrete and stones. So it is much similar to a firewall, but it is much stronger and much sturdy because it is made of stone and other concretes. The next one is tsunami. You are very familiar with this one. Tsunami is a huge sea wave triggered by a violent displacement of the ocean floor. Okay, remember that the ocean floor is also a land or a ground, and tsunami will activate when there is a sudden movement or massive movement of the ground, such as underwater earthquakes, volcanic eruptions, or landslide can cause tsunami. As it approaches a shallow coastline, its speed decreases, but the height of the tsunami increases drastically, bringing so much damage to nearby communities. Tsunamis can also overwhelm sewage system, destroy structures, and kill people. The next one is liquefaction. Earthquake motion can turn loosely packed water-saturated soil to liquid, or what we call liquefaction. Liquefied soil becomes less compact and ultimately lose the ability to support roads, buried pipes, and of course houses. Liquefactions happens underground. Liquefaction refers to a certain chemical reaction wherein the elements underground will transform into a less compact solution, or mura siyag liquid type from the word liquefaction. 'Di ba underground, for example, under sa tuang streets or underground is composed of mga hard minerals such as rocks, soils, and other elements. So in case of liquefaction, this is a process wherein those elements will transform into a liquid-like solution. This happens because of the continuous movement or vibration of the underground. So maybe the motion or vibration of that place of the underground of the ground of that certain location is irregular. When that happens, liquefaction may occur, and kung naay earthquake mahitabo in that area, that's the time nga muhugno gyud ang ground. For example, as what we can see in this picture, and that also explains why some roads during earthquake na ay mga roads or street ang mahugno gyud. That is because of liquefaction. So not just makrak but mahugno gyud. Another result pod ani is of liquefaction is that it might affect the building, mag-collapse ang building, bridges, and other strong structures. The reason for that is na if ever mahugno ang foundation, and of course, mahugno pod tong mga gipang tukod ibabaw sa foundation. So for you not to be confused, the damage of the liquefaction starts underground because the elements will become liquid-like. So not literally nga liquid but it will soften. Where in fact dapat magyud hard na ang mineral sa ilalom, for example sa tuang roads, in order to sustain a massive amount of weight. It is caused by vibration or saturation with water, which causes the soil to decrease in density. So aside from vibration, it is also caused by kanang sigig kabasa. Kanang sigig kabasa ato ang underground. This poses danger for it leads to unstable structures of buildings due to ground subsidence. The last one is fire. Although fire is not a direct result of earthquake, but during earthquake, fires cannot be prevented. Earthquake can cause fires, even moderate ground shaking can break gas and electrical lines, severe fuel lines, and overturn stoves. To further complicate things, water pipes rupture, so it would be impossible to extinguish the fire. So buildings, structures, man-made structures are composed of different objects that might start a fire kung naay earthquake. For example, sa kusina pa lang nato daan, there are different objects that can trigger a fire in our area. Okay? Another example, we also have gasoline stations and other structures that might uh, possess a possibility to start a fire during earthquake. We are now done discussing the different effects of earthquake, the primary and secondary effects. Let us now proceed with the methods of reducing earthquake risk. So remember that earthquakes is a natural disaster and we cannot prevent it. All we have to do is to reduce the um, possibility of further destructions during the occurrence of earthquake. Before we proceed, I want you to define earthquake risk from particularly the term risk since we already talked about that one during our previous discussion. Please pause the video and try to recall the definition of risk before you proceed with our next topic. You may pause the video and play it again once you are done. Please pause the video now. I will assume that you already had your answer. Allow me to elaborate the definition of risk. It is an estimation on the amount of dangers or harm that an earthquake may possess or a certain disaster might possess, in our case, earthquake. So, in other words, earthquake risk refers to the calculated or estimated amount of harm that might occur during the disaster. In this topic, we'll be talking about the different methods on how we can reduce earthquake risk or the number of harms during earthquake. The first one is the effective recording and interpretation of ground motion. As what we have discussed in the previous slides, um, the ground the ground is always moving or naadjud siya motion and vibration. There are group of experts and professionals who are assigned to monitor our ground motion and vibration. They are using a certain kind of instrument to do that one. After using after the aid of the instrument, they will be responsible for interpreting the result of their findings or the data that they have gathered. Once they have found out that the ground motion is irregular, they will have the ability to predict, know that there's certain they will have the ability to predict the what might happen in the future. For example, they might make an announcement through the news that a certain earthquake might hit this certain area based on the findings of their interpretation about their the findings of their instrument. The next one is constructing seismic hazard maps. From the word maps, so natay sample maps diri. This is mao ni ang pasabot sa second nga method. Experts and professionals will develop a map that will help people identify the area wherein a certain disaster or earthquake might occur, or the intensity of the earthquake or disaster that will happen in their area. This map is not only applicable to earthquake, it can be applied in other disasters as well. We can commonly see this kind of map during weather forecasts in television. So, kaning map is very useful when it comes to disaster prevention. The last one is developing resistant structures. These are structures such as buildings, bridges, streets, and other man-made structures that are earthquake resistant. So in other countries, they already have their buildings which are resistant to earthquake, meaning their building is strong enough to hold itself during a massive an outbreak of earthquake, and it is able to protect the people occupying their building. It is not just applicable to buildings but also in other structures such as what I've mentioned, bridges and streets. Developing engineered structural design that are able to resist forces generated by seismic waves can be achieved either by following building codes based on hazard maps or by appropriate methods of analysis. So this is thanks to our professionals. There are, I think it is Japan, wherein they already have buildings which are resistant to earthquakes, because in Japan earthquake is medyo common na silahang earthquake, and it always occur how many times in a year. I also saw one post on TikTok about it is a content, and it have a person taking a video during an earthquake in their apartment. So naagi siya sa kinatumyan sa building, and yet relax ra pod kayo siya. And of course, he is that person is safe while recording the video inside their building ha gauyog-uyog yun. It is kanang maklaro gyud ganay earthquake because the water in their bathtub is kanang gauyog-uyog, and then mo magbisik-bisik bitaw, and mo na maguyog gauyog-uyog gid siya. And that would be the end of our lesson 7. Please proceed to the activity after this video. Thank you and see you again next meet.